Alright, fifth period, this is Coach H. Sorry I can't be there today. I've got to be at a funeral, so keep us all in your thoughts and prayers. But it doesn't stop the fact that we've got to get this physics stuff done. What I've prepared for you guys is a little video here that's going to run through the problem that you guys had yesterday on the quiz, at least one of them. But obviously they're both solved the same way using the same method. So I'm going to run through it, show you how to do it. Obviously you're not happy with your results. Most of you have redo written across your paper. So what you're going to do is you're going to watch me do this one. You're going to follow the process, and then you're going to take another quiz. I have another paper there prepared for you so that you can retake the quiz and do better on it. I'm obviously not going to put a crappy grade in there for you. You're going to master this stuff. Anyway, that's where we are, so pay attention. That goes for you too, Kyle. All right, here we have a cannonball shot 2,100 meters. It's in the air for 11 seconds. It asks us to find the initial velocity, and it asks us to find the angle at which it was shot. So what I'm going to do, this is our cannonball that was shot 2,100 meters right here. But I'm going to superimpose the little triangle we're going to use, because as soon as I see this angle right here, I know that I'm going to be using SOHCAHTOA. Come on, that ought to be the first thing that comes into your mind. So SOHCAHTOA. Well, to find SOHCAHTOA, I've got to find these pieces of this triangle. And this thing gives me enough information with this 2,100 meters horizontal. That's a horizontal number. And this 11 seconds right here, it gives me enough information to find the horizontal velocity. I'm going to use the velocity equals distance over time formula to do that. When I plug in the distance 2,100 for 11 seconds, I wind up with 190.91 meters per second. All right, so that's going to go right here, 190.91. Now, I still need a vertical. I don't have enough information to find an angle or a hypotenuse here, which you got to remember now. This right here is my vertical, my horizontal velocity. This one right here is going to be my vertical velocity vectors, and this right here is going to be my initial velocity vector. The hypotenuse is going to be the initial velocity. The initial velocity is always at a particular angle. Sometimes it'll be at an angle, sometimes it'll be, the initial velocity will be fired horizontally, but it's however the projectile is fired is the initial velocity. So this one happens to be fired on an angle, so this hypotenuse is going to represent the velocity initial. All right, so I have the velocity horizontal. I've got the velocity, I've got to find the vertical velocity. To do that, I'm going to use, guess what I'm going to use? Distance equals 1/2 AT squared, so that I can find the distance to go along with my time to find that velocity. Well, when I plug in my time right here, I wind up with 148.225 meters. All right, when I plug in the time, which is half of 11 seconds, which is 5.5 seconds. That's a clue. That's important. That's a clue that you know it's only in the air for half the time. We're only considering it going up here. So we want the initial velocity that it was fired at going up. So we use the 5.5 seconds because we're only considering half the distance here, or half of the time it's in the air. Anyway, to get that, it gets my distance. All right, when I find my distance, then I can plug that into the velocity equals distance over time formula. But there's a problem when I do that. I'll show you what that is. But I get a velocity here of 26.95 meters per second. All right, when I plug in this distance right here, and I use 5.5 seconds right here. Let me change these colors so you can see them. I take this distance and put it here, and then I take this time and put it here, or because that's what I'm considering. I wind up with this velocity, but it's only an average velocity. You'll see that sometimes. That little thing means an average over it, but that's an average velocity that it takes for this object to start at the ground and get to the peak, to go from here to here. Well, we know that this velocity right here is going to be an average, because up here the velocity is 0 and down here is when it's the fastest. Well, this velocity here is an average, so it's going to be in the middle, 26.95, and so we have to double it to get 53.9. I believe that's what it is. Yeah, so when we double 26.95, we get 53.9, because when we take 53.9 and 0 and find the average, we get that. So that's how we get our vertical velocity. Now there's another way to find that, 53.9 meters per second. So I'm going to put that right, I'm going to erase this part right here so that you guys can put this 53.9 in there. I'm going to change it back to blue, my little pen, and make this 53.9 meters per second. Alright, this one's obviously meters per second. Now, there's another way to find that. Some of you guys probably figured it out, that I could use acceleration, v2 minus v1 over time. When I plug those numbers in, I should get 53.9. Alright, because my initial velocity is what I'm trying to find. The final velocity was 0. The acceleration is 9.8, and my time was 5.5. Alright, so when I plug those numbers in, I should get 53.9 meters per second. Alright, either way we'll get it. I'm just showing you two different ways to get there. Alright, so anyway, now I've got this. Now I can find this by using the Pythagorean theorem. Blah, blah, blah. I'm not going to show you, I'm not going to go through all those numbers, but when I do that, I find out using the Pythagorean theorem, which is a squared plus b squared equals c squared. When I run through all of that, I wind up getting 198.37 meters per second. Alright, that's, now I have my initial velocity that I was looking for here. The only thing left is to find the angle. Well, to find the angle, all I'm going to do is find, there's a bunch of different ways I'm going to do it. I could do it, but I'm going to use inverse tan, which is going to be equal to what is it? Tangent is SOHCAHTOA, opposite over adjacent. Alright, so the way I'm going to do this is inverse tan of the angle. I should put that in there. Alright, so what I'm going to wind up doing is plugging this in my calculator like this. Tangent, inverse tangent of 53.9, because that is the opposite of the angle that I want right here. Okay, that's what I'm looking for. That's the opposite. And this is the adjacent. So I'm going to put that over 190.91. And when I plug all that in, I'll find out that my angle is 15.76 degrees. Voila! Alright, I hope that helps. You're awesome. Have a great day.